What's up, everyone, and welcome to our virtual Nights Under the Stars event here. We will be trying to put on a video like this about once a week, and so we figured we would start off with learning more about how to observe and how you in your homes and in your own little quarantine bubbles can still get out and observe the stars and the planets, because we have a lot of very interesting astronomical events coming up this fall. So, welcome to Nights Under the Stars, brought to you by Robinson Observatory at the University of Central Florida. So, looking at star charts, we see that star charts have gone back many, many thousands of years. Even the first star charts that we see were just drawings of stars on cave walls. And although these stars didn't really pertain to any particular configuration of stars, we still saw like some representation of stars being observed. And it wasn't really until the Egyptians and the Aztecs and the Mayans when we really started to see that these astronomers were starting to put together where these stars were and really observe the patterns in these stars. And so here we see a calendar from the Aztecs that it might not look like a calendar, but it depicts different seasons and different motions in a circle of various different months and events that occur in the stars. And so this kind of acted as their calendar, and they could correspond this with what was going on in the stars and know when to harvest crops and when to make certain sacrifices and perform certain rituals. And we see something similar in the Egyptian culture as well. And this might look a little bit more familiar because a lot of the constellations tend to still be rooted in the Babylonian system, which is where we get our horoscope system from. And so we can see things like this lion here, which is Leo, and like the scorpion is supposedly potentially Scorpio, or Cancer. And so going around, we see that there are these different representations that look a lot like some of the constellations in the zodiac that we recognize today. And this even transformed into Europe in the 17th century, where these drawings got passed down through the years, and we still see similar features, such as here we see like the feet of the lion, we have Leo, we have a scorpion. And so really we have these differences then between astrology and astronomy, but they tend to overlap a lot. And so there tends to be a lot of confusion between what is astrology and what is astronomy, and how do these kind of intertwine. And really that intersection where they intertwine is on the ecliptic plane, where we see our zodiac. So astrology tends to be a bit squishier in terms of Western science, in that it is often used to predict personalities or moods or life events based on the position of celestial objects. And so you typically hear about like someone being born with the sun in a certain sign, and this essentially corresponds to potentially that person having a certain path that they grow up along, or having a certain personality type. And this was used a lot in ancient calendars because they did really follow mostly that same zodiacal pattern, and really used that to base what their current events were And we see that astrology and the studies of astrology tend to focus primarily on bodies in the ecliptic plane. And this is basically the region where the zodiac constellations are. And this makes a little bit of sense because we do see the most variation and activity within this region of the sky, and I'll go into that a little bit more coming up. But we tend to have a focus on that in astrology. Whereas astronomy tends to take more hard measurements and observations of celestial objects, focusing on the entire sky. So this also includes the northern constellations and the constellations that are not in the ecliptic plane that tend to not show very much variation. And it tends to be accepted as science by Western cultures, mostly because of the hard measurements and the verified observations that we have. So the ecliptic plane is basically how we perceive the motion of Earth around the sun. And so we see the Earth here rotating around the sun, and from our point on the Earth, when we look at the sun, to say that it is in a certain constellation, we essentially see what constellation is behind the sun. And so here in this example, the sun is in quotes, Leo, because essentially the sun is covering up that constellation. And so constellations are more than just these outlines of stars that vaguely represent some sort of shape or story or character, and they really actually follow a certain region in the sky. And so each constellation has a sectioned out region, much like the states in the US. And so when the sun enters that region that we have defined, we can say that the sun is in that constellation. And in reality, these stars for these constellations are many, many miles away and nowhere near our sun or our solar system. And even the stars within a constellation might not be near each other, but it's how we perceive it. And so, because of how the solar system is set up, we have our sun at the middle, and then the planets are roughly in a plane going outward, like kind of like a disc, like a plate. And so when we look out at the solar system from Earth, the planets tend to, and the sun tend to fall somewhere along this plane. And it appears as a line in the sky. And this line is called the ecliptic. And so this line right here, which has the zodiac constellations along it, is where we see the planets moving, we see the sun, and we see the moon. The moon does have a little bit more variation from the ecliptic because it's in kind of a different system, but generally we still see this trend of the plane of the solar system falling along this line. And the line varies in the sky throughout the time of the year and where you are. And so if we're on the equator, say like right here, and we are looking straight out, we tend to see that the ecliptic will be directly overhead at what's called the zenith on the fall equinox. And so this is when the sun will have on the equator 12 hours of sunlight and 12 hours of night. And this is because it will go straight up to the very top of the sky and then set directly in the west. But if we are somewhere else, such as Orlando, like we are here at UCF, we see the ecliptic at the equinox at 28 degrees south of the zenith, or the spot that's directly above us in the sky. And this is because the whole Earth is tilted, and we are up higher. So being up here, imagine the sun being overhead here, we have to look south to see the sun. And we see that also at the North Pole. So at the North Pole, you would have to look south to see the sun at noon on the equinox, and it would be on the horizon. And this is just because of position on the Earth. So the solstice, the summer solstice and the winter solstice, change where the ecliptic is going to be in regards to the equator, because we have this tilt to Earth's axis. And so in the north, in the summer, the sun will be over here and will be receiving a lot more direct sunlight on the north. And so on the equator, the sun on the summer solstice will not be directly above. You will have to actually look further north, about 23.5 degrees, to see the sun. So if you were at a latitude of 23.5 degrees on the summer solstice, you could look directly up above at noon and see the sun. And similarly, the winter solstice, we have the sun over here where there's more sun in the southern hemisphere and there's less in the north. And so if you're on the equator, you'd have to look south to see the sun. And so if you're in Orlando, we'd have to look not only the 28 degrees south, but also the 23.5 degrees south before we could see the sun at noon on the winter solstice. And so if you can imagine, at the North Pole, this is why we tend to have longer days in the summer and shorter days in the winter. And so you can have something called the midnight sun up in the Arctic Circle, where the sun just never sets. And that's essentially because it's far enough up north that the sun is always visible. So there's this region up here where the sun will always be shining. And so the ecliptic can actually be really useful when it comes to observing. So this is what our modern star charts look like today. They're roughly the same, actually, as some of the older star charts from like the Egyptians and 17th century Europe. However, we tend to also draw out a lot more of the actual line structures, and we know a lot more about the bodies that can be observed. So we tend to see the ecliptic here. This is from October 6th at about 9 p.m., I believe. And we'll find the different planets in October, and this fall we'll be seeing Jupiter and Saturn a lot more, and Mars. And so they're all going to fall along this ecliptic plane. And also you see like Aquarius and Pisces and Aries and so the zodiac falls along this line as well. In the north here we have the Little Dipper, and as you can see in Florida, at least in Orlando, at this time of year the Big Dipper cannot be seen, which makes it a little bit more tough to observe, but we can also see Cassiopeia and Cepheus, which I tend to use a lot more when trying to locate objects because they're very bright and they're usually up in the sky. At least one of them is. But Polaris is special here because it's the North Star and it does not move in our sky in the northern hemisphere, and it can only be seen in the northern hemisphere. And so if we were on the North Pole and we looked directly up, we would see the North Star and it would not be moving, and everything else here would be rotating around it. So when using a star chart, first thing you need to do is locate where north is. So here I just use the compass on my phone. And then next you're going to lift up your star chart to basically hold the star chart as if it is your sky. And locate north. And you're going to want to align the north on the star chart with the north in real life, where you are. Kind of like a backwards 3 or an E, or I guess occasionally an M in the sky. And the Little Dipper tends to be very dim. So these two stars here are part of the Little Dipper, and these other two make the rest of the basin. And the end of the handle to the Little Dipper is Polaris. And that's one way to find the Little Dipper. However, it tends to be very dim, and so occasionally we can use the Big Dipper down here, which tends to be more noticeable, to then follow the outer edge of the ladle directly up to find Polaris. So I usually start with these objects when I'm looking for different objects in the sky. And so it's kind of important to take note of some objects that are brighter than others. This will really help, especially if you're in an area that still has a lot of light pollution. It tends to be more obvious which objects are brighter because they're going to be the ones that you can actually see, rather than the smaller objects which are covered up by the light pollution. And it's really important to find something that you know well first. And so for me, that's Cassiopeia. I always seem to be able to locate that one. But maybe there's another constellation that works better for you. Maybe it's Orion. Maybe it's the Big Dipper. Really just find one constellation or one object that you know really well, and then you can kind of use the star chart to find other objects that are nearby and kind of like trace your way across the sky. Also, knowing the latitude of your location will determine how high the North Star is in your area. And so it's really useful to, before you go out, especially if you're in a new area, make sure you know your latitude so that you aren't looking too high in the sky or too low in the sky for some of these northern constellations. And of course, as much as we love science, it's always safety first and science second. So when you go out observing, even if it's just in your backyard, make sure to tell a buddy where you're going or bring someone with you, and tell them when you plan to return as well. It's really important because a lot of areas where there's less light pollution, tend to be more rural, and if something happens, it's good to have someone nearby who can help or know when to get you help. Along with that, watch where you step. A lot of common observing accidents happen from looking up in the sky while also walking around. So if you plan on walking around somewhere, maybe look down first, and then once you get to wherever you want to look, you can stop and look up again. Also, make sure to wear closed-toed shoes and clothing to protect against bugs, because especially in Florida, there are a lot of mosquitoes out there and a lot of different branches and such that you could trip over. And also bring water, because it does get pretty hot. And since we are in the middle of a pandemic right now, make sure to protect yourself and those around you, and don't forget to wear your mask. So a couple star chart resources that you can find that I tend to like are the heavensabove.com. It also has an Android app. This one's a really neat website because it allows for tracking of the ISS and different satellites. It also has a live updating star chart, an interactive star chart, so that you can kind of just put it up in the background and it will update while you're out observing. Skymaps.com is also pretty good for getting star charts. It is free, which is great. It's pretty basic. It doesn't have an interactive feature, but you will be able to get star charts for your location on different days. And Stellarium is an Android and iOS app that I found is useful. It's one of those ones where you can kind of like follow around in the sky and hold your camera up and it will tell you what your camera is looking at, essentially. I think this app does cost about like $5 or so, but it is pretty useful if you don't feel like using an actual star chart. And I will be putting the link to these different sites in the video description, so don't worry too much about scrambling to copy these resources down. And thanks for your support. Really, we've been making these videos for all of you, so please subscribe to this channel for more astronomy content each week. We're going to try and have some short video to put out each week about different astronomy topics. And follow us on Twitter at UCF Planetary and UCF Observatory. And if you also wish to donate to the Robinson Observatory to help support our outreach programs, such as this one, please see the link in the description. And I hope to see all of you out there and observing. Thanks.